Alright, so this was your very first ever C++ program, I believe. We have a total of 11 lines in it. First and second lines are what types of lines? These are comments. And we know they're comments because we have a what?
Double slash.
Double slash at the beginning, exactly. Line number 3 is this # include IO stream. Basically what we're doing with that is we're reaching out and we're sucking in a lot of code that other bright, smart people wrote for us. So that's very cool. 4 is a blank line, 5 is another comment. 6 is int main paren. You will have this in every single program you ever write. It basically defines where the main routine is. If you're the C++ compiler, you always start to run the program, you run the main routine. You can have a zillion different routines, I don't really give a darn. I'm always going to start with the main routine, so you will always have a main routine. The main routine is surrounded by little squiggly brackets, so I got one here and I have one at the end. Inside my main routine, I have a standard : cout, which is basically the C++ equivalent of print. Okay? I have 2 less than symbols going into cout, saying these symbols, these text strings go into here, and then they pop out on your screen. It says, quote, hello world, \n, quote. What's the \n do?
New line.
New line, exactly. The line is ended with a semicolon because all C++ lines are ended with a semicolon, and I can put a comment at the tail end because I put 2 slashes. I have a return 0, just that simply says the main routine sends the 0 back to anybody who happened to call it, and then I have a squiggly bracket done, and poof, that's it. That's the whole program. It's 11 lines, and most of them are pretty much comments. It only does one thing, and that one thing is it. Print hello world. Poof, that's it. A lot of effort for a little output, but that's cool. Now, here's an interesting contrast. If I was going to do this exact same program in Python, what would that program look like?
Print hello world.
How many lines would that consist of?
One.
Okay. So a little bit of a contrast between Python and C++, right? Python, you can knock this one out in 1 line and be done with it, right? C++, 11 might be a little long, but you're still looking at probably about 5 lines of code to print out hello world, right? Does C++ seem like a suck language? So look, C++ has a lot of strengths to it, okay? But there is a lot of overhead associated with C++. I had to put that main routine in there. I had to include the IO stream thing. So there's a lot of additional things you have to do. Now this is great for team projects. This is fantastic and wonderful for large projects. C++ is great for that. If you have to just knock something out, like it's a one-off and it's going to be like a throwaway, Python's probably a better language for that, right? You're going to do a large-scale project, you're going to write Microsoft Windows or Microsoft Word or something like that, C++ is probably a better one for that. So really, hopefully what I hope you get out of this is to understand that each computer programming language you learn is effectively a tool. It's a hammer, it's a pliers, it's a screwdriver, and when you're faced with a job, different tools for different jobs, right? Okay. Now let's screw things up. So you still have the program, right? Okay. What I want you to do is delete line number 11, which is the little squiggly bracket, and try and run the program. Give it a shot. See what it tells you.
Error expected bracket. Match this one error.
What does it tell you when you run your program?
Error expected bracket.
Bam. Okay, so you're starting to see what an error message looks like, right? And that was actually relatively clear, right? It's looking for a bracket, okay?
It won't even let me build.
Okay. No, it won't let you build because you've got a fundamentally a syntax error there, right? Okay. After you do that, do me a favor, put line 11 back. Basically type the squiggly brackets, okay? Then do me a favor, on line number 8, delete one of the double quotes and then try and run the program. So on the hello world, you can get rid of the first one and the second one, I don't really care. Get rid of one of the double quotes and run it and see what you got. What does the machine tell you?
Error expected primary expression or return.
Yes, that error message isn't quite as clear, right? It doesn't say you're missing a double quote, right? But it's trying to tell you that something's wrong on that particular line, right? Okay, that's cool. We're good with that. Do me a favor, put the double quote back. Here's my personal favorite. Do me a favor, save this program as the program name, but put a .c at the end. Not a CPP, but a .c. And then go ahead and run it. And you'll discover Dr. Anderson's show. What happens when you run it after you save it?
I can't even build still.
You will know. You shouldn't be able to. What does it say?
It says IO stream file not.
IO stream. No, now, is that clear? Is it saying, by the way, you really meant to have a C++ program, but you saved it as a C? Absolutely not. Did it flag IO stream?
Nope.
Yeah, it should be doing something you could see other. But yes, and it did, right? And what it's saying is in the C language, because you saved it as a C file, IO stream has no meaning, right? And the # IO stream has no meaning whatsoever. It says, so I'm compiling a C program. This is goofy. I don't know what's going on. So should you ever see that error message, the one that you have hopefully on your screen right now, understand that what happened was you saved the file as a C file, not a C++ file. All you have to do is change it to a C++ file, and that error will go away. You got other errors? Well, that's your own business. All right. Cool. All right. I think we ran through a bunch of errors, experienced them, and now we can move on. Dun, dun, dun. So let's do a little CSI in your program, shall we? Let's dive in and figure out actually what's going on there. So this is a Sony Walkman. Back in the day, the coolest thing. Slap in your cassette, you could listen to it. This is a Sony Walkman taken apart, which is actually sort of cool if you think about it. But obviously there's a lot of bits and pieces to it. Well, if we could take a Sony Walkman apart, it sure seems like we could take a computer program apart, right? So let's do that, shall we? All right, so here's our first program. So we had 2 lines at the beginning, okay? They were both comments. Comments both, they begin with double slashes, indicating that the remainder of the line is a comment. You can put anything you want on there. You can put math on there, you can put strings on there, you can put a letter to your mom on there. The computer no longer cares. Once it sees the double slash, it ignores the rest of the line, because it doesn't really matter to it, okay? You put comments in to document your programs and to help other people read them. Specifically in this class, you put comments into your program so that the TA, when they're looking at your program, can figure out what the heck you're doing in your program. If you choose not to put comments in your program, there's a good chance the TA will not know what you're doing in your program, and that will make the TA very, very, very angry. And that will not work out well for you. So when you're writing a program, should you include comments or not?
Yes.
Yes. Dang straight. Okay? Comments don't cause the computer to perform any action because they're ignored. Okay? And a comment begins with double slash is called a single line comment because it terminates at the end of the current line. Okay, that makes perfect sense. You can also use C style, which begins a comment with a slash, star, and ends with a star slash. So C has a slightly different commenting style. C++ can handle that too. Comment is a comment is a comment. Little suggestions from me. First few lines of every program, you should write some comments. So in other words, you should have a header comment in your program, right? What program is this? What's it trying to do? When did you write it? Who wrote it? For that sort of matter, right? You write a piece of software, leave it for a month, and come back to it. You think you're going to remember what that software does? No freaking way. You better have a header comment in there that explains really to you as much as anything else what's going on. You want to give the name of the file that contains the code. That's always important because if I print out the code and I'm looking at it and going, wow, I should go back and change this. Am I necessarily going to know what file it is? Not if I didn't put the file name in the header comment. Then you want to include your name, who created the code. Then you want to include the high-level description, just exactly what the code does. And the reason for doing all this extra work is because next week, next month, next year, you will not remember what this code does. Okay? So put in some comments to make sure we know what's going on. Taking part in our first program, so we've got this preprocessor directive on line number 3. Pound, include, less than, IOStream, greater than, and a comment that says allows program output to the stream. Okay, so this statement is called a preprocessor directive. What that means is that the compiler will never see this command. Okay? But the C++ compiler has something called a preprocessor. So before the code gets sent to the compiler, the preprocessor runs. It finds this line, include IOStream, and it goes, stop. You would like me to include some additional C++ code that you did not write. Not a problem. I'll reach out and get the library called IOStream. I will put it into your code, make your code significantly longer, and then that's what I'm actually going to submit to the compiler. Okay? Da-da, which is a message C++. Okay? This line notifies the preprocessor to include in the program the contents of the input-output stream header IOStream. This header must be included for any program that outputs data to the screen or gets anything from the keyboard. And we're just putting stuff on the screen right now, but it does both ways. Next one is line number 4, which is a blank line. Can you include blank lines in your code?
Yes.
Is it going to cause any problems?
No.
Okay. So once again, we go back and say, when you're writing your code, I urge you to include a lot of blank lines in your code. So if you got a chunk of logic, that's fantastic. When you move on to the next chunk of logic, put some blank lines in there. Once again, the TA will become very upset with you. There's no blank lines in your code. Okay? Blank lines are free. Use them as much as you want. And you use them to separate different parts of your program. Here's where I'm getting the input, here's where I'm processing the output, and here's where I'm producing my output. Should all have nice big blank lines between them, perhaps filled with some comments too and stuff like that. You really want your code to be readable. If you don't have any blank lines in it, it's going to be a really dense chunk of code, and nobody's going to want to read that. You can use blank lines, space characters, and tab characters to make programs easier to read. Together, these characters are known as white space, and white space is completely and totally ignored by the C++ compiler. So you can tab things out, you make things look all pretty, you put in blank lines, and the compiler says, I really don't care, and it strips them all out before it does its compile job. So all that stuff is just for you. The main function on line 6, int main and two parentheses. The main function is part of every single C++ program you will ever write in your entire life. The parentheses after main indicate that main is a program building block called a function. Okay, so this is not a variable, this is a function, and we know that because it has the two parentheses after it. C++ programs typically consist of one or more functions and classes, so you'll find a lot of these, not called main, but a lot of other ones. Exactly one function in every program must be named main. You cannot have two, you cannot have three, you can have one. C++ programs begin executing a function main, even if main is not the first function in the program. So it doesn't matter if it's at the top or the bottom, the C++ compiler will find it, and it will start to run your program at main. Okay? By the way, you can actually put stuff in this parentheses if you wanted to get input from the command line. If I'm running the program and I put, run coolest person in the world program, Jim Anderson, right? That command line would actually be passed into the main routine through the arguments there. Line number 6. What was line number 6? I have no idea. Main function. Anyway, so we have main. Oh, it must be the squiggle bracket here. Squiggle bracket, squiggle bracket. The keyword int to the left of main indicates that main returns an integer. So if, when your program got all done, if it produced some sort of results, this is my count the number of people in the United States program. It runs and then it comes back with a single number, and that's what it is, then that would be what it would be returning. It's going to return an integer in this particular case. A keyword is a word that is reserved by C++ for a very specific use. So integer, what's an integer? It's what? What are whole numbers? As opposed to half numbers? Cool, that's very neat. What is a whole number? 1, 2, 3, 4, 5, 6. Are those whole numbers?
Yes.
Let's contrast that with 1.1, 17.6, 8.5. What are those?
Real.
Floating point, real, decimal numbers, right? So what's the difference between a floating point number and an integer?
Floating point will be a lot more,
We're going down a bad path. No. See, you've already said too many words. What's the difference between a floating point and an integer?
the decimal.
Decimal point. There you go. You got it. Nailed it. Very good. So if a number has a decimal point, what type of number it is? It's a floating point. And if it has no decimal point, it is a integer. Bingo. Exactly. That's exactly what you need to know. The left brace here must begin the body of every function. A corresponding right brace, line 11, must end each function. So you got it. So it's a little sandwich. A little piece of white bread on top, a little piece of white bread in the middle, and you've got peanut butter and jelly in between. Fantastic. Reserved words. See these words? Never use them for variable names. Okay? So C++ has some words that it recognizes and it does stuff with, and you should not use them for variable names. Things like and, not, private, friend apparently, I'll figure that one, operator, public, throw, using. These are all reserved. Okay? So they're not available for you to use as variable names. Is that a big deal? Absolutely not. Okay? The world's a big place, lots of other things. There's also some common words in C that you can't use, such as if or int. Those are already being used by language. Don't use them as a variable name. Output statement. Okay, so we got, what is it? Standard, colon, cout, less than, quote, hello world, \n, quote, semicolon, and then a comment. Okay, that's what that is. This command instructs the computer to perform an action, specifically to print the string of characters, hello world, contained between the double quotation marks. White space characters in strings are not ignored. So I have a little space here, a little space between hello and world. That's fine. The computer's actually going to print it out with a little white space in between that. So that's cool, but remember if I had a zillion white spaces here, the computer would go, I don't care. Okay? But if it's in a string, it does care. The entire line, including standard out and the less than operator and hello world and semicolon, is called a statement. So this is a statement. Okay, every C++ statement must end with a semicolon. Right there. By the way, if you don't end with a semicolon, guess what the compiler is going to tell you?
What is that?
No, it's not actually going to tell you that. Unfortunately, it's going to tell you something really weird. Like, I'm having problems with the next line. You're like, wow, why are you having problems with the next line? Oh, I forgot a semicolon on the line before. It's basically how that works.
Or backslash and.
All sorts of stuff like that. Preprocessor directives, like include, do not end with a semicolon. Oh, dang it. Ah, good point. Include IO stream, but there's no semicolon. Why? Just to be difficult. Yes, sir?
Because it's not main, it's separate from the actual main meat of the code.
It is, but lots of stuff isn't in main, right? So I don't know if that's, you're right, like, there's no problems with that, but I'm not sure if that's actually a good explanation as to why there's no semicolon. I think it's just because they were drinking beer and they said, whatever, that's good enough. Sir?
I would think it's because the preprocessor deals with it, not the actual compiler.
And that's a good point. They're being processed by something besides the compiler. So it's not actually really, quote, quote, part of the C++ language, right? So and that actually works as a possibility. I don't have any problems with that. All right, so we got that one taken care of. Output side, I think output and input in C++ are accomplished with streams of characters. So the way they want you to think about this is hello world \n. It's a stream of characters. I mean, it could be 1 character or 100 characters, it doesn't much matter. But it's a whole bunch of characters, and these characters, listen, flow into the cout command. Woo, flow into, and then it does something like send it out to the screen. Thus, when the preceding statement is executed, it sends the stream of characters, hello world in this case, to the standard output stream object, which happens to be the screen. You can actually, I think you can redirect it, so it could go to a printer or something else if you want to, but that's good enough for right now. All right, your code can be dense and hard for you and everyone else to read, so indent. So what did we talk about? We said include comments in your code, that's good. We said use white spaces liberally to separate different chunks of your code, that's good. Now we're saying go ahead and indent. So basically, you don't actually have to indent. C++ compiler doesn't care. Unlike Python, C++ doesn't give a dang about indentation. You should, though. So if all this block is inside of a while loop, you better be moving it over so we can tell that it's inside a loop. If all this stuff is part of an if statement, move it over so we know it's all part of it. Pick how many spaces you're going to indent and then just stick with it. Generally, a good rule of thumb is 3. 3 spaces seems to be a good indenting. You could do 10, but pretty soon you're going to be off the right side of the screen if you're not careful. And we go for that. What else we have? Standard namespace. Okay, so this is where we get a little bit funky. Just a tiny, tiny bit funky, but let's go through it for a moment. So it says standard : cout. So the standard before cout is required when we use names that we brought into the program by the preprocessor directive, include IOStream. So did you write cout? Did you spend a weekend figuring out exactly how you were going to set output to the screen in C++? So you're using somebody else's code, right? All right, if you're using somebody else's code, you got to own up to it every time you use that code. Okay? The way you own up to it is you said, I got this code from somebody else. Go ahead and use the code. Okay? So in this particular case, when you bring in include into your main program, it puts it in what's called the standard namespace. No big deal whatsoever. So that means whenever I want to use cout, I got to tell the C++ compiler, yo, I did not write this. So do me a favor, look in the standard namespace and see if you can find this function. Okay, no big deal whatsoever. Okay? Okay, notation standard : cout specifies that we're using a name, in this case cout, that belongs to the namespace standard. Think of it as like a bookshelf. There's a bookshelf. That bookshelf is called standard. If you want to use cout, since you did not write it, you have to say, yo, go look at the bookshelf, the old standard bookshelf, and get the cout routines. The names in the name cin, coincidentally, which is how you actually get input stuff, and cerr, which is the standard error stream, also belong to the namespace standard. So you do standard std : cin, standard : cerr. For now, you should simply remember to include standard std : before each mention of cout, cin, and cerr in a program. Make sense? So the print statement's a little bit more complex in C++. You got to put the standard : thing before it and be good to go. We will take care of that later on with a secret technique, but for right now, that's what you need to do. Okay? The stream insertion operator and escape sequences, standard : cout, less than hello world \n. Okay? The less than operator is referred to as the stream insertion operator. Okay? So we're taking this collection of characters and we're inserting it into the cout stream. When this program executes, the value to the operator's right, hello world, is then inserted into the output stream, which is cout. Notice that the operator points in the direction of where the data goes. The hello world goes into cout. Huh? The right operator's characters normally print exactly as they appear between the double quotes. Perfect. Okay, we'll go to that. All right. So, but we've got this \n character. What does \n do? New line, right? So I'm printing along. I hit a \n. What do I do? And where do I go on that line?
Beginning.
Very first character, exactly. That is 100% correct. It's called an escape character. It indicates a special character to the output. When \ is encountered in the string of characters, the next character is combined with the \ to form an escape sequence. And \n means new line. Of course, that does mean a little bit of a problem if we ever want to use a \, right? We're going to be sort of screwed. So if we actually wanted to use a \ in our output, how would we do that?
Double \.
Very good. That is 100% correct. So two \ makes a single \. Escape character sequences, \n is new line, \t is tab, \r is carriage return, a is an alert, makes a bing sound, \/ is obviously a \/ single quote, \/ double quote. So if you wanted to print single quotes or double quotes, you can do it. You just have to put a \/ in front of it. Okay, the very last statement in our program is return 0. Okay? Statement is one of several means that we'll use to exit a function. It means we're all done with the little main program. When the return statement is used at the end of the main, as shown here, the value 0 indicates the program has terminated successfully. So we did return -1, what would that mean?
Sentinel value.
It means we had some sort of problem going on, right? According to C++ standard, if program execution reaches the end of the main without encountering a return statement, it's assumed the program is terminated successfully, exactly as when the last statement in the main is returned is the value 0. And for that reason, you will never see this again. So basically, if you get done and there's no problems, it returns 0 anyway. You can have the whole return 0 thing going on, but just why sweat it? It's going to do it for you automatically. This will be important when we do other routines and other methods and want to send a value back. But for the main routine, it's not really that important. Okay, time to make some changes. Software exists to be modified. Customer requirements are always changing. You will spend more time modifying existing code than writing new code. That is God's truth to you. Okay? Majority of software development is actually making changes to code that already exists. That's how we get Windows 7 and 8 and 10 and all that sort of stuff. Right?
8 actually just got discontinued as well.
8?
Yeah.
No.
They have
Internet
this-
Explorer 8 got discontinued, but not the
Yeah,
operating
no,
system.
Explorer, yeah. 8's doing fine.
No, they actually discontinued.
No, they did not.
Yeah,
They did not discontinue Windows 8, no. Because there's too many people using it.
They really did.
Yeah, Windows 7 is supported.
You can slip on it.
Yeah, Windows 7 is fine.
Windows 7.
Yeah.
Windows 7.
What's the last Windows that actually got discontinued? I think it was
Windows
95.
XP.
Wasn't it 95?
It was XP on April.
You're exactly
in
right.
April
It was XP.
2014.
You're right. XP's dead, but everything else is fine. I mean, it will get discontinued, but not yet. All right, so let's see if we can make some trivial modifications to our code. Trivial means it doesn't really much matter, but let's do it anyway. So here's what we have: standard : cout hello world \n. Now we're going to change it to a standard cout hello. Second line standard cout world \n. Okay. So the first string is going to print hello followed by a space, and because the string did not end with a \n, the second string begins printing on the same line. Okay. Tiny little thing that we're doing here, we're playing a little game, we're just printing out stuff and it's all on the same line. So this very first line, standard cout hello, prints, and then we stay on the same line. Second thing comes along, we print world right here, we've got a \n, now we go to the next line. So if you want to print multiple things on the same line, this is exactly how you do it. Silly little change number 2, standard cout hello. Standard cout world line, that's where we stand right now. Let's change it to this. Standard : cout hello \n world \n. So what's that going to do?
First hello, new line,
Sorry, what was that? You all seem distracted. You all seem to be typing. You're taking notes. That is so cool. How about if you go ahead and hit the little power button that's in the lower right-hand corner of your screen? Send it off to sleep so you can have complete and total fascinating focus on my \n discussion. Because it gets no better than \n. It really, truly gets no better than \n. This is as good as it gets for you. Anyway, I'm sorry. So I've got my hello \n world \n. What's that going to do?
It'll print hello, go to the new line, then print world, then two new lines.
Bingo. That is exactly correct. Okay. Mistakes that you're going to make when you do coding. Forgetting to include the IO stream header in a program that inputs data from the keyboard output. You forget that, things go to pot pretty quickly, right? You don't include that, you bump into the first cout and it's going to go, I have no idea what you're talking about. Omitting the semicolon at the end of a C++ statement is a syntax error. You will do it 1,000 times because everybody does it. Understand that it will not actually tell you that you've forgotten a semicolon. What it's going to tell you is that the next line it's going to start to struggle with because somehow things don't quite work out. So when you take a look at that next line and go, wow, there's actually nothing wrong with that line, what you're going to have to do is look at the line before it and go, wow, I wonder if I'm missing a semicolon. And the answer will be yes, you are missing a semicolon. All right, things you need to do. Good programming. Every program should begin with a comment that describes the purpose of its program. We call that a header comment. Indent the body of each function one level within the braces that delimit the function's body. This makes the program's functional structure stand out. So you got a brace up here that starts at brace down here. You should push all your code over so we can tell that the code's part of that particular block. And good programming practice, set a convention for the size of the indent. 3 works, 5 works, 10 works, 100 works, doesn't matter. Whatever you want to use. Just be very consistent in your code. So what did we cover today? We talked about displaying data on the screen. Yay! In particular, you learned to use the output stream object cout to build simple display programs. Hot diggity. How fantastic is that? That's really great. Okay? So what we're going to cover next time, we'll talk about how variables are stored and retrieved from memory. That'll be good. We'll also learn how to use math operators to perform calculations. We'll discuss the order in which C++ applies operators, which is really, really important. So what's more important, plus or times?
Multiplication.
It should be time.
It is, that is correct. You will learn how C++'s if statement allows programs to make decisions, and finally we'll introduce the equality and relational operators which you use to form conditional if statements. Wow, what an action-packed class that will be. Oh, we got C++ stuff to do, and we will do it in exactly 10 minutes. Righty. So let's talk a little bit about C++, shall we? Today we'll be talking about use cases. Okay. Oh, hey, look, it's another job posting. Let's see what we got going on here. Okay. Responsibilities for this particular job that they're hiring for are management of the design, layout, and production of client, server, and web-based applications. Okay. Performs a developer role in building enterprise software solutions encompassing services and service layer, service integration to the user interface, and data and user interface components. And the candidate must work well in a team-like atmosphere in the development information technology solution for a wide variety of public sector clients. So what does that tell us? Who are their clients? Government.
Either government or the public.
No, it's a government. It's really good. It really is government. We're working on government contracts. Okay, what do you need to do this job? Bachelor's degree in programming, computer science or related field, plus a minimum of 3 years of related experience. Experience in C, C++, coding methods and practices 2 to 5 years, and a working knowledge of Red Hat Linux operating system. That's not really a detailed set of requirements, is it? I mean, you don't need to have that much to get this gig. You got to know Linux, got to know C++, and you're good to go. Think maybe after this class you can land that job. You can at least have a talk with them, right? I mean, you're cheap. Right? Not going to be any cheaper in your life. All right. So let's talk about today UML, which is the Unified Modeling Language. And the reason we're going to spend a little bit of time talking about UML is because when you start to develop these C++ programs, you're not going to be doing it by yourself. Okay? You will create your code. You will create, more importantly, your design. And you'll probably be working as a team of software developers. What that means is that you need to have a way to share your design with other people. A lot of different ways to actually go about accomplishing this, but it seems like we should come up with some sort of like standardized way. Otherwise you're going to be sitting there going, well, I'm thinking you have a class. The class is going to have like 4 methods, and the methods are going to, it becomes silly very quickly, right? Now you guys have talked to other people about your Python programs, probably. How did you talk with other people about Python? I didn't talk to other people. The first rule of Python Club is what?
Don't touch that.
Generally in the world of something like Python, if you were going to talk to somebody about your program, or if you're going to try and show them how your program works, you'd probably draw a flowchart, right?
Yeah.
Go here, don't do this, this is what you do. That's standard, 100% standard. The problem when you bump into C++ is now all of a sudden you've got an additional layer of complexity. We haven't gotten to it yet, but we'll get to it. Of like objects and methods and some other complex things that make that a little bit more of a challenge. So what you really want to do is you want to talk about how different things talk with different things. And flowcharts aren't going to cut that, so we need to come up with something else. Unified Modeling Language, UML, is a general purpose modeling language in the field of software engineering, which is designed to provide standardized ways to visualize the design of a system. It was created by a very smart man called Grady Booch back in the day. Okay? 1997 was adopted as a standard by the people who do standards and stuff like that. It's well known and widely used in education, like here, but it's not that well used out in the real world. And the reason is because most people out in the real world never learned it in college, right? Generally what most firms use is some sort of bastardized version of UML. So they do it, but they don't do it quite right, which is fine. It doesn't matter. As long as you know what UML is, you'll be able to jump into the conversation. Okay, so we talk about UML diagrams. There's really three classifications of a UML diagram. First one is behavior, second one is interaction, and the third one is structural. Behavior diagrams is a type of diagram that depicts behavioral functions of a system or business process. And this is activity, state machines, and use case diagrams as well as the four interaction diagrams. Interaction diagrams are a subset of behavior diagrams, okay, so a subset of this one, which emphasize object interactions. This object talks to this object, talks to this object, talks to this object, okay? And structural diagrams are a type of diagram that depicts the elements of a specification that don't have anything to do with time. This includes class composition, structure, component, etc., etc., etc. There's actually like 23 different types of diagrams you can do in UML, which is crazy. What it means is a whole bunch of really smart people got together and just went crazy. You only use a few of these diagrams in the real world. Okay? So this lays out all the different types of UML diagrams you can do. Okay? There's structural diagrams over here, and there's behavior diagrams over here, and they go on and on and on, and nobody uses all of them. Okay? So today what we're going to do is we're going to take a look at a diagram. It's going to be a behavioral diagram, and it's going to be a use case diagram. Okay? So we're going to take a look at that one. Use case. So it brings up an interesting question. What is a use case? A use case is a list of steps that the system needs to follow in order to meet a goal. All right. That sounds handy, if nothing else, right? You have to define what's required and how those requirements are going to be met. Do not try to write the code when you're writing a use case diagram. So we're not talking code at all. We're talking about a picture that shows how the system's going to operate. Okay? And it consists of a bunch of shall versus should requirements. Okay? Use case generally includes interactions with an actor, human, or an external system. They like to use the phrase actor. So you'll hear a lot of actor stuff going on. Use case description. Here we go. Bank customer enters their card into the machine and then types in their PIN. Bank security then verifies the card. The user selects the account to use, checking their savings. They then select an amount to withdraw, $4 million. Security verifies the amount that is available. You only have $20. The system makes a decision as to whether or not it's going to provide the money. User selects how they want to get their money in 10s or 20s. Security provides the funds. If possible, security provides a receipt and returns the card to the user. Does that sound like every single trip to the ATM you've ever had in your entire life? Let's see if we can make a picture that shows how this goes.
I've seen some of it.
Go down that. It looks like every trip to the ATM, doesn't it, Mr. Gage? Yes. Can you say yes?
Yes.
There we go. That's what we want to hear. Great. So, when we're creating our diagram, we need to have a trigger. What starts this process off, the trip to the ATM machine? What's the very first thing you do? Put your card in. Okay, that's a trigger. Bink. All right. Actors, outside of system boundary lines. So we're going to have actually sort of two actors in this one. One is going to be you, the customer, right? The other one is going to be the person that you're quote, quote, talking to, and that's going to be bank security that's going to determine whether or not you get any money, right? You're broke college students, you get no damn money. Okay, all right. All right, preconditions. We're going to assume that you have a secure connection to the bank, okay, before we start anything, and we're going to assume actually the bank has money. The bank has no money. You've just signed up for the worst ATM machine in the entire wide world, okay? Wow, well, we know if we're successful. We've got to have goals. Well, if your account is still secure when we're done, yay! And oh, by the way, if you get your cash, okay? What we consider, is that acceptable? Is that goals? UMLs, we got to figure out what we're trying to accomplish, right? So we get, before we do this, let's make sure that we're on the same page as far as what we're trying to do. Okay. All right, use case description. So what could go wrong with your trip to the ATM machine? First off, wrong card. Apparently it doesn't want to eat your library card. Go figure. Okay. PIN, it's only 4 freaking digits, and yet you still forgot it. Way to go. What part of 1111 did you not actually write down anyplace? Insufficient funds. Ouch, that just hurt. Okay. ATM has insufficient funds. You'd like to have $20, but I only have 5. Over your daily limit. Go away, come back tomorrow. Okay? Or even worse, you stole that card. Okay, those are all bad things. Okay, alternatives. Okay, so if you screw up your PIN number 3 times, eat the card. You're obviously stole it. If the card is identified as being stolen, eat the card, right? So those are possible things that could happen, right? Oh, I'm sorry, what is that?
I guess they can already do that.
Oh yeah, no, they screw it up, buddy, and I'll show you what happens to
Well,
your
never
card.
stolen cards, so there you go.
Give me your card. Alright, so let's see what we got going on here. Woo. So I guess we want to figure out what we're going to, okay, well, that's probably what we turned it. Alright, so let's see how this goes. So the customer inserts the card. One of 2 things can happen. Number 1, the card could be invalid, correct? Number 2, it could be eject the card, or else the card is validated. Good, good card. Excellent, let's move on. Customer enters the PIN. PIN is invalid. See ya, okay? PIN is invalid 3 times. Card is marked as stolen, or PIN is valid. Yes, continue on. You select your account, which is either checking or savings. The account is selected. Oh, you're over your daily maximum. You're over your account funds available. You're over the funds in the machine. Ask for a new amount. Okay, that's all fine. We can work through all those issues. Select desired 10s or 20s. Provide the funds. Provide a receipt, and then eject the card. So that's sort of your sequence from the different sorts of things that could occur as you interact with the ATM machine. Correct? Da-da-da! Your use case. A gigantic red glowing mass. Okay, so let's take a look and see what we're dealing here. Okay, so this is effectively the ATM machine. This is actually what you look like to other people. Good news in the weight loss program, it seems working really, really well. You might want to start eating some more, okay? You are considered to be an actor, okay? These little lines that go into the ATM machine are considered to be communication lines, okay? It's a general use case, okay? This is just a note. Hey, this is a bank customer. Cool, all right? So we go up here. So the very first thing you do is you insert your card. There's some includes. They're going to verify your card. They may double check with their security system to see if it's a stolen card. Next thing you're going to do is enter your PIN. Once again, they're going to double check to see if it's stolen. After that, you're going to select your amount. Selecting your amount indicates whether or not you want to get it in 10s or 20s. They will verify the funds to make sure you actually have the cash to get what you want. Assuming that that all works out, they're going to provide you with the funds, and they're going to provide you with a receipt, and they're going to actually eject your card. Meanwhile, over here is another actor. This particular actor is the bank, a bank security system, right? Ching, 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 ching. And it's a system boundary line. We already talked about that. And that each one of these are individual use cases. So we could dive in and put a lot more detail on those later on. But overall, this shows the use case diagram for our little ATM thing. We've got a couple of actors, and we've got a lot of actions going on between them. So we could actually talk about your design using this, right? If I came in and said, you know, when somebody's using the ATM machine, I would like to present them with an opportunity to invest in these CDs that the bank has, right? We could go, well, you know, I got a process here. Maybe before I provide them with the funds, because I got their attention, I could stick another thing in here that says show about current CDs and ask if they'd like to take some of their money out of their checking account and put it into the CD. I can put it right there. See, so now I have the ability to have that type of discussion because I have a layout of exactly what's going on, because I've got this UML use case diagram. So, what did we do today? We talked about what a use case is. We went through the excruciating detail of building a use case description, and we took a look at what a use case diagram looks like. You are now UML experts! Well, no, but you're a little bit better off than you were. Are there any questions about UML or use cases? Excellent. I've beaten you to submission. My job here is done. Fantastic. We are done for now. Let's take a look in your C++ toolbox. You've got C out and in, which you had, but now you also have # include. That toolbox filling up? It is, isn't it? How exciting. In case you want to spend some time over the weekend doing a whole bunch of includes. Not really, actually, but that's okay. All right, so what are we going to cover next time? We're going to calculate the biggest and the smallest from a group of numbers. It has never been done in the Western world, but in this class on Monday, we will be doing that. So bring some safety goggles, just in case something goes horribly, terribly wrong. Okay? All right, I will see you on Monday.